Okay, we'll look at some of the homework problems that are in section 10.1. And here we're going to be using the pictograph on the left. This is problem number 1 to answer this question. How many of the players at bats were singles? And this is the pictograph that we'll be looking at of a person's or a player's at-bat record. And we want to find out how many of those at-bats were singles. Okay? Now, here in this case, we do have the title, and then the icon represents 4 times at bat. So here we look at the row that says singles, because that's what we're trying to find out. Here we have 5 baseballs. Each of those baseballs represents 4 times at bat. So if you multiply 5 times 4, you're going to get 20. So in this case here, the number of the players at bats that were singles were 20. So in this case, this player had 20 singles at bat. All right, let's take a look at the next problem. Now here we're going to be looking at a stem and leaf plot right here, which represents the weight of the students in pounds of all 14 students in this case. And this is in a junior high classroom. And you remember what a stem and leaf plot is. The numbers on the left-hand side of the bar are the stems, and the number on the right side are your leaves. And then you have a legend where 7/3 represents 73 pounds. And here, we want to use that stem and leaf plot to answer the questions like this one. List the weight of each student who weighs between 80 and 89 pounds. Okay, let's look at our stem and leaf plot. And we see we have 3 numbers under the stem of 8. That's 82, 84, and 88. So there are 3 students who weigh between 80 and 89 pounds. Okay, and those weights are 82, 84, 88. Okay. And then part B, what is the weight of the lightest student in the class? Well, from that stem and leaf plot, we look at the lowest number that's in this stem and leaf plot. That's the 7/3 representing 73. So the weight of the lightest student is simply 73 pounds. And then, what is the weight of the heaviest student in the class? In this case here, we go to the stem and leaf plot, where you have 11/6, which is the highest number there. That represents 116 pounds. So the heaviest student in that class weighs 116 pounds. Okay. All right, let's take a look at some more problems. Okay, in this case here, we want to determine which histogram represents the data in the stem and leaf plot at the right. And here's the stem and leaf plot that we're looking at. And then we're given these 2 stem and leaf plots, these 2 histograms to determine, and we want to look at this to determine which one represents this stem and leaf plot. Okay, now, by looking at this stem and leaf plot, I see that there are 3 numbers that are between 60 and 70, and only 3 numbers that are between 70 and 79. Now, if you look at the stem and leaf plot, you notice that this will not work because there are more numbers in the 70-79 range than there are in the 60-69 range. Well, on the right side, this would work because there are only 3 numbers in the 60-69 range and 3 numbers in the 70-79 range, which is what we have in that stem and leaf plot. And there's 6 numbers for the 90-99 range and 100-109 range. So this particular histogram would be the representation of this stem and leaf plot. Okay. All right, let's take a look at the next problem that deals with a bar graph. And in this case, the bar graph shows the number of workers who are unemployed in a city during the first 2 months of 1997 and 1998, during which month of 1997 were the greatest number of workers unemployed. And what was the total number unemployed in 1998? Okay, let's find out during which month of 1997 were the greatest number of workers unemployed. Okay, in this case here we want to look at the bar for January of 1997, that's bar A. And then for February 1997, that's bar D. We want to look at which one of those has the greatest number of workers unemployed. And by looking at it, it would be D. And that represents February of 1997. Okay, so we'll select February, which is the month during 1997 with the greatest number of unemployed workers. And then the next one, the total number of unemployed in 1998 was how many thousand workers? Okay, B and E represent the number of unemployed workers in January 98, and E represents the unemployed workers in February 98. By looking at this, under B, there were 6.5 workers unemployed. This goes up to 6.5. And for E, this goes up to 7.5. So if you add 6.5 to 7.5, you'll get 14. So that means that there were 14,000 unemployed workers in 1998. Okay, let's look at the next problem, which deals with the stem and leaf plot. In this case, a company employs 20 people whose ages are listed on the right. Answer the following questions from the information given on that list. Now here you want to choose the correct stem and leaf plot for this set of data. And you can see that there are 20 pieces of data here. And you want to select the one that has 20 stems in this set of data. And by looking at this, you can see, or you can count up, that this would be it. Because it has 6 plus 3 is 9, plus 5 is 14, 16, 20. 20 stems here. The other one does not. It only has, let's say, 5, 10, 13, 15, 16, 17, only 18. In the stem and leaf plot, you must account for all of those numbers. You must account for all 20, even if they repeat. So the first one represents the correct stem and leaf plot for this set of data. And from that, we can answer the question, are more employees in their 40s or in their 50s? All right, take a look. There are more people in their 40s than there are in their 50s. So we check the one that says 40, because 5 people are in their 40s and 2 people are in their 50s. Next question is, how many employees are younger than 30 years old? Okay. We see that there are 6 people that are under 30. So here, there's 6 people that are younger than 30 years old. And then the last question in that problem, what percentage of the people are 60 years or older? Okay, in this case here, there are 4 people who are at least 60 years old. So it's 4 out of the total of 20. Now, if you want to change that to a percent, multiply that by 5, because percent is always over 100. So it'll be 20 over 100, which is just simply 20%. Or you can do 4 divided by 20, then times 100, which will give you that 20%. So 20% of the people in this particular situation are older.